Hey folks, before we get started, I just want to let you know about my upcoming book, The Max Coder's Guide to Finding Your Dream Developer Job. If you're looking for a job or you think you might be looking for a job in the future and you're trying to up your mobility and meet new people and things like that, this book walks you through the whole process. Go ahead and check it out. It comes out on November 20th. It'll be on Amazon, and you can find it as The Max Coder's Guide to Finding Your Dream Developer Job.
Hey everyone, welcome to another episode of Ruby Rogues. I am David Kimura, and today on our panel we have Andrew Mason.
Hello.
And today we have two special guests. We have Khash, Sajadi, and Kasia Hoffman.
Hi there.
Hi guys.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
Would y'all mind explaining who you are and why y'all are famous and who y'all work for?
I wouldn't say I'm famous, but so my name is Khash and I work for a company called Cloud66. We started Cloud66 back in 2012 with an aim to make Rails deployment easy and specifically to help infrastructure easy and understandable for application developers. Naturally, as you would imagine, with infrastructure and deployments and all that kind of boring stuff getting into more and more containerization, Docker, Kubernetes, and all other things, we moved more and more into containers and Kubernetes. And we also run Cloud66 itself as a Rails stack. We have a fairly chunky Rails stack that powers quite a few customers that we have. And we moved that onto Kubernetes. So I think on the way of building a product that helps other fellow Rails developers and running our own Rails stack on Kubernetes, we learned a few things that hopefully we can share with others.
Cool. And so I think that nowadays a platform as a service, so like Cloud66, there are several different alternatives out there today, like specifically Heroku or Elastic Beanstalk. So what really sets Cloud66 apart from those other kind of services?
That's a very good question. We get that quite a lot. And frankly, this is the question that started Cloud66 for us because, as multi-cloud Heroku users, and I should categorize this into PaaS or public PaaS, platform as a service providers like Heroku, which Heroku was one of the first ones. We started Cloud66 while we were Heroku users, and we kind of thought, we're going to have to answer this question ourselves and kind of why that's the case. Interestingly enough, we looked around a lot into different products. We talked to a lot of customers and companies and friends and consultants and influencers, and you name it. Anybody who had an idea could help us with answering that question. Why everybody starts with Heroku and why very few larger websites carry on running on Heroku. And this is not just just anecdotal information that we hear everywhere and we go talk to people, but it's empirical. If you look at websites and services that provide backend information for websites, you see that the number of new websites that sign up with Heroku, for example, built with is one of those services that provides you with backend information of publicly available websites. If you look at that, the number of websites that start with Heroku usually are around page ranking of 1 million plus. And the ones that fall out is around when they get into about 50,000 page rank. It seems to me that the trend is everybody starts out with Heroku and nobody carries on running on it as soon as they get to a certain scale. I have to say that a lot of obviously good businesses carry on running on Heroku, and there's nothing wrong with that. And this is a question that started Cloud66. We wanted to answer that question. We believe that the answer to that question is going to be, if there is a legitimate answer, it's going to be a business. What we realized is that the answer is not in technology. It's not about features. It's not about any of those things. It's not even about lock-in into a specific company. Heroku's got a very good technology, very reliable technology stack. They use containers and virtualization way before it was cool. So from that point of view, they've done a really great job around this. They also evangelized and popularized a lot of concepts that we are now familiar with, from stateless application, 12-factor, proc files, and all the sort of things that we now, a lot of time, we take for granted. They were popularized by Heroku, so they have taught us a lot from a technology point of view. And from a lock-in, Salesforce is bigger than Rackspace from a market capitalization point of view. And a lot of people are happy to just run their entire stack on Rackspace. But then when it comes to Heroku, they go, well, it's a lock-in. So we realize that it's not actually a lock-in. And a lot of companies and a lot of folks out there are very happy to have a quote-unquote lock-in with a smaller business, a non-public business, and that's not an issue. So why is that? And we realize it's in the unit economy of public PaaS. And what I mean by that is, for Heroku to provide you with a great seamless experience that they do, they need to own the entire stack. They need to own the layer at the very top that connects with your Rails application and all the way down to the server. Now, they run on Amazon, obviously, AWS. But what I mean by owning it is that you are completely divorced and decoupled from infrastructure. And that's what's make it a great experience, because there is nothing that you need to do, know, or break when it comes to the infrastructure side of it. And that gives it a great infrastructure experience. However, with that comes another cost, and that is, for Heroku to be a profitable business and to have the prices competitively priced, they need to be everywhere that there is a cloud provider. And what I mean by that is, this happens quite a lot where Amazon opens up a new data center, say in Singapore or like in Australia, and then all Heroku customers who are still running in Ireland or North Virginia, they would go and say, well, I need to be closer to this. Why? Why is it not there? And you would ask, why is it still that Heroku has very few availability zones? And I think the answer is that for it to work, you need to have Heroku everywhere that there is Amazon. And that is not a trivial task, because from a unit economy point of view, you need to make money for every one of those business units. And that means that you need to have enough customers around it who want it and make that a profitable unit. So the unit economy for Heroku is a data center. And that data center's location is not decided by anybody in Heroku, but with someone up in Seattle from Amazon that decides for very other reasons other than Heroku's requirements where that data center should be. So your unit economy is very large and very big, and it's bound to somebody else's business metrics, which means Heroku, after 10 years or so of operation, they still have 2 availability zones as far as I know. While there were other cloud providers who tried to break that. So if you remember, there was the father of all the Cloud Foundry things was this company a long time ago that they started doing this, rolling out Cloud Foundry to any data center that Amazon or Rackspace will open up. So they would just go and say, you know what, the issue with Heroku is that they are not everywhere. We want to make sure that we are everywhere. So they rolled out Cloud Foundry-based PaaS everywhere. And again, they faced this unit economy because very few of those became profitable. Everything else was loss-making. So that seems to be the case of like public PaaS. Heroku, everybody says it's expensive. Some people say, well, it's expensive, but it gives you great value and a great service. But the reality is that as the prices of virtualization server goes down, Heroku prices don't change. And the reason is it's a very expensive operation to run as a platform everywhere. So you have a bill of, say, $10,000 that everybody pays, and the typical, going to say, like a Heroku bill of $10,000 a month. $3,000 goes to Heroku, $7,000 goes to a lot of other vendors that are in the marketplace, from SSL providers to a MySQL and time series databases or whatnot. All of this goes out. So it becomes totally very expensive for the customer for a value that they think they can get from open source projects or going directly to talking to AWS and getting VMs from it. So that's one side of the economy. The other side is the cloud providers who are always coming up the stack and they provide more and more functionality. You mentioned cloud formations and other things around PaaS and now managed Kubernetes that kind of is eroding into the value of the PaaS. What we decided that we wanted to do, and this kind of long answer to a very short question, what we decided to do is to break that unit economy from a data center to a server. So what we thought is that we're going to have a trade-off. We're not going to own the entire stack. we're going to deploy what looks like an experience from Heroku onto your own servers. So you go anywhere you want to go. We talk to the public APIs of those cloud providers within the data center that you choose, that your account is, and we provision, deploy, and maintain your application the way that you used to with Heroku on that data center. What it means for us is that if tomorrow another cloud provider shows up, DigitalOcean, or whoever else that might be, and they decide they want to have a data center in Russia because of political or compliance reasons, we can be available there immediately. We don't need to make money from a business unit there. We make money from the single customer we might have there, and that's pretty much enough for us. For every unit economy being a server and a customer to return that. And that made Cloud 66, that's been going on for 7 years now, a profitable business that's been growing every year and year. And that's the thing that we see. And just like another evidence of that is that a lot of other PaaS providers that are not snapped up by, for example, Salesforce, which is the parent company for Heroku, and they don't have as a result a deep pocket, just go out of business every year. We have these campaigns that we run that take care of customers who have been left high and dry by businesses, past businesses that go out of business every year.
Cool. And so we had you guys on the talk today to discuss Kubernetes and Rails. And so how does Kubernetes fit into the Cloud 66 model if you guys are managing the servers for the clients?
This is a kind of a result of a series of decisions that we made. Back in 2012, when we started the company, we were focused on web applications, mobile backends, and APIs, and it was only Rails. Soon after, we had a lot of customers who were very satisfied with this, but they didn't like the fact that they had other stacks and other languages or frameworks that they couldn't run on Cloud 66. So they had to log into Cloud 66 for their Rails and then go other places to do other things. So we opened up a Node as a product, Node.js. And in 2014, we were looking to make Cloud 66 more generic and more polyglot to support more languages and frameworks. And we thought containers, and specifically Docker, and this is back in 2014, could be a very good technology to enable us do that and serve our customers better. So we would put everything, the customers put everything that they want, regardless of the language or the framework, inside of a container. We manage the container. Inside is theirs, outside is ours, and we can provide them with the same experience. So in 2014, we released Cloud 66 for containers. Back then, obviously, Kubernetes or Mesosphere or Docker Swarm they didn't exist at the infancy. So we wrote the whole scheduler and networking layer and everything on top. We partnered with some very good companies to provide a bunch of services around that to roll it out. That was 2014. In 2015, there was, if you remember, there was a competition essentially around the containerization grace of infrastructure. It was Kubernetes, Mesosphere, and Docker company, which rolled out Docker Swarm. So those are kind of the three main contenders around this. And then there's Nomad from HashiCorp and a bunch of other proprietary products out there. We looked at all of that, and we, being application developers and pragmatic Rails developers, we wanted to just choose the best technology. So we went with Kubernetes. We thought that's the best one. We made another bet. We put everything on that. We replaced our scheduler with Kubernetes, and we went all the way in with Kubernetes. And luckily, we were right about this. All of the other technologies and companies either didn't get anywhere or started supporting Kubernetes, and that became the de facto standard for containerization. So if you think about it, we started a product with Rails. We wanted to make it generic, and we chose, luckily, the best technology out there to make that generic containerized infrastructure work for any framework. Now, when it comes to Rails, this year we're kind of going back home. We're going back to our roots. And what we're doing is that we're providing the Heroku-like experience that our customers are familiar with our Cloud 66 for Rails product, but then we backing it with Kubernetes. And there's very good reasons for that, because we are a Rails shop and we did that ourselves, and we are benefiting from it tremendously, but we wanted to kind of share that with everybody else. So this year we are rolling out Kubernetes for Rails product that we have. It's not a new product, it's a new experience on top of our existing Kubernetes product, but it would make deployment of a Rails application onto Kubernetes extremely simple the way you're used to it with something like Heroku.
And so that's pretty interesting. So typically, when deploying a Rails application, you could get a DigitalOcean droplet And this is talking beyond Heroku. So now you are taking ownership of some servers, whether virtual or physical. So you could spin up a $10 droplet on DigitalOcean. You can install your Ruby on Rails application, your SQL service, and then whatever else. And then you could have this living pet that you maintain over time. And there's not much redundancy in place there, obviously. So if that server ever crashes or you have to reboot it and it just doesn't come back properly, then your application is essentially down. So then you move on to more of a managed infrastructure to where you might have multiple droplets that are automatically provisioned from your CD pipeline. And all of that sits behind a load balancer with those droplets being created as needed. So if one of them does die and go down, then it'll automatically provision a new one and then redeploy the application onto there. You have your database in a separate instance or on a RDS service with like Amazon. And that seems to be pretty sufficient. It can horizontally scale quite a bit, and it can also scale vertically with your droplets. You could just make them larger or smaller, however you need, and that can handle quite a bit of traffic. So at what point would someone on a production instance decide that they have outgrown that kind of infrastructure and now need to move to something like Kubernetes? So where's Kubernetes really bringing the benefit for a monolith style application?
That is a very good and valid question. So first, let me just be clear about one thing that I don't think it is realistic and wise to think that something like containerization in general or Kubernetes specifically is going to be the best solution to run an infrastructure for any kind of application at any size in any organization. That I think we can agree on that. That's not necessarily always the case. There's horses for courses. There's, you're going to have to choose the best thing that fits not just your technology stack, but your organizational requirements. If I'm a lone developer, solo founder, starting out, even 5-6 years into my business, and I have a lifestyle business that I'm very happy with, and it's been running for a long time. Pinboard is a good example. The solo developer of just a bookmarking service that charges people. It's a very good business. He's declared, the owner has declared that, he doesn't want to grow this. It's just what he wants to have. It would be foolish to suggest, you can run this on Kubernetes. He would come back and say, I've been running it for 6 years and it's absolutely fine. So why are you telling me something to fix something that's not broken? So that's the first thing I would get out of the way. But on the other hand, there is also a non-technological kind of part to any decision. What we've seen as in, being in this business for a while, and we now serve, about 12 to 13,000 Rails developers and about 1,000 companies that are our customers. And, we talk to them quite a lot, is that they arrive at the containerization or the Kubernetes answer not necessarily from the same point of view. So there's no inflection point that you would think, I get to 5 servers or I get to the team of 3 and now it's Kubernetes time. While that might be the case, there are different reasons for it. And a lot of those are not necessarily based on technology or what is the best technology to run on my stack, what's the high availability and what's the scalability, is it horizontal and vertical, but it's about how my organization works. I've hired my 6th developer. Do I need to have a site reliability engineer? And I have a remote team. Is Kubernetes or a containerized system is going to be a better solution for it now that I have a remote team? And those are kind of other things that are not necessarily applicable to a team of 500 plus or 1,000 plus headcount, but it could be very much a reasonable question to ask when you're starting out. And what we found is containerization specifically can help a lot with distinguishing boundaries and responsibilities within a team. So you can think of it, it works in a container. So we just think about the outside, devs are inside the container, ops are outside. So you don't have this thing of it works on my machine, throw it over the fence, or somebody jumping on a weekend onto a server and changing SSH to a server and change something and it just makes things work, but nobody knows how. And when they are on vacation, then everybody's kind of sweating. Those are kind of organizational challenges that a lot of things around Kubernetes can help, and I can get into why technology can help with that. But to answer specifically around what you're referring to in terms of, I can go to DigitalOcean, get a $10 node and a droplet and kind of be very happy with it. I can relate to it from our own experience. So as I said, we run on Rails, and we've been running on Rails for 3 years before, 4 years perhaps, before we decided that we need to move on to Kubernetes. So our just a brief what our stack looks like. It was a Rails stack, as you know it. We had MySQL as a backend, one of the backends. We had Redis using it as a as a kind of a persistent cache and memcached, all that kind of stuff. Nginx was at the front. Puma, I think, or Unicorn, I'm not quite sure back then what it was, as the application server. And that was kind of a typical, run-of-the-mill Rails stack running on EC2 at AWS. I think back then we were running on maybe 12 or 13 EC2 instances. The first instance that we felt, we are kind of in a straitjacket when it comes to expanding our infrastructure was when we wanted to add a search functionality. Until that point, we were relying on MySQL's text search for search functionality provided to our customers. And at one point, it was not adequate. It was not cutting it anymore. So we thought maybe Elasticsearch is one, Sphinx another solution that we can use. And while those are kind of easy to implement and kind of plug into Rails, there's a great deal of gems and documents and wiki pages and GitHub repositories of how to do this and add search. There is an operational aspect to it. How do you keep an Elasticsearch instance up and scale it? How do you do that with Sphinx? And we kind of realized that this number is kind of growing. We have now queues and search things and other things that we're going to have these components up and running. We kind of need to know about those, as if we need a SQL search, Elasticsearch guy now hired. And one of the things that we kind of realized when the light bulb went on was that if we learn how to keep one thing up, and that's the Kubernetes cluster, then everything else that sits on top of it should technically be much easier to maintain. Because, as you said, if you build an infrastructure that you can take out a bunch of servers just without prior notice, and that your infrastructure stays up, that's the kind of the big challenge. Once you get over that hurdle and you can have a reliable, resilient infrastructure grid, then you can put a lot of not necessarily inherently stable things on top of it, and it helps a lot with the stability of the whole thing. So with that, we went on a mission to do this. And I think that's the question with a lot of folks that they want. They don't want to have what you mentioned as, you rightly referred to as a pet, that it's a kind of a living, breathing creature. If you get an email from DigitalOcean that says, the physical under that VM has an issue, just turn it off and turn it back on, and it will migrate automatically to another physical machine, you go, oh no, I don't even know if I shut it down, it's going to come back up again. That kind of stuff, we don't want to be in that situation. The other thing is, you have a lot of utilization issues where you want to have servers that come up and are configured for, say, this function, like search function, and you have another server that comes up for your background processes or your front end, and you have these different ones, and each one has a little bit of spare capacity, and collectively you have 12, 14, 50 servers with a lot of collective spare capacity. You want to shrink those things down. You want to get away from what is known as snowflakes, like these servers that are kind of slightly different but kind of similar. You want to have uniform servers that you can just add new ones to it. You want to be able to upgrade when there is a upgrade, or where you patch when there's a security vulnerability. All of those things that you want to do once, and you want to do it only one way, in a uniform way, you can take care of it with something like Kubernetes. The whole kind of premise of this is around not only building this universally highly available cluster that then you can put your applications on top of it, whether it's a 3 server or 300 or 3,000 server grid, but it's also about another very critical point in my point of view about how is this set up. Now, we're all familiar with Googling how to install MySQL on Ubuntu, like a very popular Google query search. And a lot of those answers land on, say, a page on DigitalOcean or Linode, where you go and see a bunch of commands, apt this, apt that, sudo that, curl this. And people go there and SSH from one. There's an SSH terminal on one monitor, and there's a wiki page on another monitor, and there's a lot of copy and pasting going around. You copy something like sudo apt updates this, and then you go to the next one, and you hopefully the script is well written and well maintained, and you get to the end of it. But the reality is that you have to follow steps, as in these recipes, these cake recipes that you have to follow to end up with the cake that you want. And hopefully the recipe is well maintained and the measures are correct and everything's fine. So you end up with the actual cake that tastes good in MySQL that's running at the end of it. But the way Kubernetes looks at this is kind of different. It kind of looks at it and says, what does the real world look like? What does the desired world look like? And I'm going to make the real world look like the desired world. Leave it to me. And it kind of this is kind of like a magic kind of cooking thing, is like, show me a cake. Oh, you don't have a cake. Let me print you a cake. That's the kind of the analogy where, very weird when it comes to cooking. But this is essentially what Kubernetes is different from things like Chef and Puppet, where you have these scripts that you have to kind of nurture and craft, is that you just tell Kubernetes that you want to have a server that looks like this, or a container that looks like this, or an application that looks like this. And it will go and do whatever it takes to get you there. And if at any point this world starts to kind of diverge from what you desire, as in, a network card starts to fail, or something crashes, or, anything else that you said is going to be slightly different, it will tell you, and it will get into this loop of correction that will try to bring it back up and make up for the deficiencies and this gap, bridge this divergent gap. So that's the kind of another big thing that we realize. So what we have is now not a wiki page or a recipe list, but a bunch of scripts or more like manifests that we keep in a repository. And we know if we throw those manifests at any cluster, a generic standard cluster, anywhere, regardless of who's the host or what operating system underlying host operating system is, it's going to bring our application up no matter what. And that's a big win when it comes to speed of delivering services to your customers.
Hey folks, I want to tell you about a great system that I just found that has made my life a ton easier. That's Cloud 66. A lot of folks think that deploying is a pain. I kind of grew up as an ops guy, and so I never really felt that way until I tried Cloud 66 and realized that the way that I was doing it with Capistrano, pushing stuff up to DigitalOcean, it really was kind of a pain. And when things didn't work, I had to go in and I had to bang my head against the wall to figure it out. Plus, all the setup stuff was just a big headache. And what I found with Cloud 66 is that it's a really nice way just to get everything set up. I just told it I had a Rails app, and off it went. It set it all up, it does the deployment, and now that I have other developers working with me on Podwrench, which is what I'm using it for here, all I have to do is give them access, and then they can go push the button for me, and it gets deployed. It's really nice. It's straightforward. It has all of my environment variables in it, so I didn't have to do any setup that way either. I just had to go in, put in my AWS credentials and a few other things that I was using for third-party apps, and it set it up and ran it. So if you're looking for a great solution for deployments, use the promo code RubyRogues, that's all one word, capital R, Ruby Rogues, for $66 off Cloud 66. This only works for new users, but man, it is awesome. So go check them out, cloud66.com.
Yeah, for me, when I'm working with Kubernetes, I've kind of boiled it down to a couple of different scenarios where I think Kubernetes is a viable solution for a production environment. And one of those is if you're dealing with microservices. So if your application has 30, 40, 50 different microservices, and if you need to deploy them, you're working in multiple one of these services each sprint, you need to deploy them all, then Kubernetes is going to be pretty awesome with that. It can load balance and scale up one particular microservice as it is experiencing higher load. And it's going to kind of keep everything versioned and the same. So I found that to be one really good use case. And it sure beats the alternative of having to deploy or try to manage the microservices without Kubernetes. And the other instance is if you have a need for a repeatable environment. So let's take the Heroku example. AWS is spinning up 9 new data centers this year or between now and next year, and you want to tap into those markets. So you're going to have to redeploy your entire infrastructure an additional 9 times. Well, by using Kubernetes, you're going to have all your configurations in a readable YAML format that you would then be able to then repeat essentially the entire infrastructure out there to your other environments, get your application stack deployed to those without any worry of configurations or anything like that. So in a production instance, I found those to be like the 2 most compelling reasons to use Kubernetes opposed to manually provisioning, or even through some sort of CI/CD automation, provisioning your instances. From a development standpoint, I also use Kubernetes in my CI/CD pipeline to provision the infrastructure for commits. So I have a Kubernetes instance that whenever I push to my development branch or my master branch, it will spin up a staging instance with a unique URL that's fully qualified that I would then be able to go in and test that environment before I actually deploy to my production environment, which may or may not be using Kubernetes, but in the underlying technology, it's going to work very similar.
Yeah, so that's a very good point. The two parts that I'm hearing is that microservices, Kubernetes obviously is built for microservices and works really well with that. But I think it's a legitimate question to ask, how many Rails applications are actually microservices? And so what benefit am I going to get there by taking on all the complexity and all the things that I have to learn or relearn, and the organizational change that needs to happen for a simple monolithic Rails application that works pretty well and it's been around for a while and we're all happy with it as Rails developers. What's the mileage? And the other side is about if you want to have a build once and deploy multiple times sort of approach around on-prem systems that you might have. And that's also another valid point. Starting with the second one, I agree with you that Kubernetes or similar systems can help quite a lot with building something once and deploying it multiple times. We do that for Cloud 66 on-prem, where we use, interestingly, Cloud 66 itself, but underlying Kubernetes to deploy Cloud 66 for multiple instances for our customers that want to have our system behind the firewall. And that works pretty well because it's yet another instance of this running the same manifest files against a vanilla Kubernetes instance. There's another CI/CD aspect to this that's not necessarily related to anybody who wants to deploy something many times. Take a kind of an ultimate dream CI/CD setup where you have your entire stack, including databases and everything from database all the way up to web, deployed every time you have a PR, every time you have a branch, every time you tag, at minimal cost and almost instantly. And that's what you were referring to, when you said you have this thing that, staging that runs there. And not only that, which is great, and, it's brilliant if we could have that, but not only that, if you're running your Kubernetes, if you're running your production stack on the same infrastructure as well, not necessarily same service, but same infrastructure setup, you would promote one of the, the staging on to become the next production. And then from there, you can have, a lot of good things or good practices within the operations or, things like blue-green deployment, canary releases, gradual releases, rollbacks, all those sort of things that you can do. And, all of this starts with a good foundation. To achieve that, you need a good foundation of repeatable infrastructure, scriptable infrastructure, immutable infrastructure. And, from that, once you have that foundation built, then the rest of it kind of almost is dividends that are just you can reap. And we are now beneficiaries of that investment that we made into building that foundation of a good Kubernetes cluster foundation, understanding of that. We built a product out of it so everybody else can do it, and we can get to that when it comes to Rails. But now is exactly what we do. We have a product called Cloud 66 SkyCap, which is responsible exactly for this. Every PR, every branch, every tag, even arbitrary Git ref, Git SHA commits that can be deployed within its entirety, database and everything, onto the same cluster at a very smaller footprint that doesn't break the bank. But then you have a URL that's necessarily encrypted. Anybody can click on it. That URL can be added to the PR. So every time there's a PR, there's a URL that shows up there, and you can just click and see how that PR looks like in reality. And if it's good, then you can promote that to become the next production. And when you merge it back, everything kind of works great. And you can imagine, I need like 2 ops people and an SRE engineer and a lot of DevOps practices to go into this, get a lot of people to change the way they code and use Git to just make this happen. But again, it goes back to that foundation that you can build. So even if your company or your product is not necessarily something around deploying it multiple times to isolated instances, having something like Kubernetes or containerization in this way with a good foundation on that can benefit best practices of development, even of a single developer, solo developer itself. Going back to the relationship between microservices and the Rails and how that can be beneficial, I completely agree with you. I don't buy into the whole new microservices. Everything needs to be broken into microservices.
I'm right there with you.
Yeah, pretty much. That's the thing you see a lot with Rails developers. We are pragmatic people. We kind of know how to use things for them to work. And I think this is a common thread that I see amongst all the Rails developers. You tell them this, microservices, break everything into microservices, and they go like, you know what? There must be a good reason, and I don't see it. So that is completely true. I come from a background of service-oriented architecture and writing things in Java and C# and before that, even more antiquated languages. And it doesn't necessarily have to be even multiple repositories. You can adopt microservices in the old terminology of service-oriented architecture in the same repository, and they are not really services that are provided with REST or gRPC or whatever newfangled protocol you want them to talk to each other. You can do that, but there's a lot of cost and complexity and all the other things that comes with it. So I'm not necessarily going to say, break your Rails applications into microservices and then the gates of heaven is going to open. To me, it is more about what am I going to get out of this repeatable, immutable infrastructure that I can just feed servers into and it's going to benefit me? And is it going to be suitable for pragmatic, practical Rails single monolithic application? And my answer for what it's worth, and Cloud 66 stack that serves a lot of customers, has been yes. There is great value in doing that. So what we are getting from that is that this is a factual true story that we've experienced, that we've had before when we were running on EC2 as a startup, starting in a while back and growing with our customers. You can imagine how many times we had to grow our servers. We had to get a new server, make it bigger, and get bigger disks, buy more bandwidth, all the things that we had to kind of grow, because those were the problems that were good problems and you can throw money at it. So we kind of started with this thing, start small, have good merits for growth, don't optimize prematurely. And then as you have these problems, start to grow. It's great that you don't, you can build a sustainable business, but the pain side is that, every 6 months, you're going to have to double the size of your servers or double the number of your servers. And this is a painful thing. Every time you go there, you want to do this again. The scripts have changed and the dependencies have changed and some packages are now redundant. And there's a new OS underlying OS that's out, then you cannot, so your servers then become out of line and misaligned, and then the whole thing kind of starts. So this used to be a super painful process for us every 6 months. Since we've moved on to this unified infrastructure, which is now powered by, in this instance, Kubernetes, we had to do the same number of times of this growth or patching or upgrades, but it has been literally a 5-minute job for us. We still are on call. We still come, everybody kind of critical people come on the chat line. We are all at the same time because we are upgrading an entire infrastructure for our production stack that's used and relied by a lot of people. But frankly, one person does it, everybody else just talks about their day, and then everybody goes home. They log out when we do it early on a Saturday morning. Every 6 months or so. The process goes as this: we create another set of servers. We basically scale out into a new group, as called in Kubernetes, with bigger servers this time. So the servers are higher spec or have a newer operating system or patched some security vulnerability, for example, that was discovered. And then we drain the old ones and we migrate the workload onto the new one. And these are the concepts of Kubernetes concepts. This is not something that I say in a drain, it means 20 steps, and migrate means 35 steps. Essentially, you run one command to tell Kubernetes to drain your servers from workload, i.e., first you cordon them off, as in you don't get any new workloads scheduled on them, and then you drain them and it migrates. So literally it's 2 commands that we run. And we've done it 3 times so far in 18 months. And we've upgraded our cluster to the latest. We just don't think about it anymore the same way. Now, you might say, I have 5 servers and I can do it manually and I have this great scripts, and that's great and valid and you can do that. But as any dynamic business knows, even if you don't change your stack, the world outside changes, the requirements, the compliance things, the growth and the numbers that you have to hit, they change. And we find that making changes when you have taken care of a highly available foundation becomes much easier when you just have to think about those numbers and how much power you need as opposed to how to build the infrastructure to give you that much power. It becomes a number of servers as opposed to, oh, now this number is 20 servers. Now I have to do this thing 20 times. And, it means a lot of script that I have to run and some of them might not work and all that sort of thing. Even for a single repository monolithic application, it works. It saves you a lot of time and money.
And so this may have changed, but the last time I looked at Kubernetes in a hosted environment, so Azure, AWS, or GCP, there was an issue with auto-scaling. So within the Kubernetes cluster, you can auto-scale your applications just fine. But the problem came into auto-scaling your actual Kubernetes clusters. So back when I was looking at Azure, it would not provision a new Kubernetes node if I started reaching some limits. Do you know if that's kind of been addressed? I know that Microsoft specifically was working on something with auto-scaling the clusters, but to me, that's kind of one of the other downside or points to Kubernetes is that one, you're currently provisioning at least 3 servers for the high availability, but then you're limited to those resources that you have on those. It'd be nice to be able to horizontally scale automatically as you start adding more traffic or more load onto your environment, which means you're spinning up new pods, but you're going to have at least 3 servers initially. So if you are a small company or you have small applications that you need to deploy, I think maybe going with Heroku or something like a managed Cloud 66 or Beanstalk or something else might be a more viable option for the short term until you do grow into a need where you need more of that managed infrastructure that Kubernetes provides.
Yes, that's a very good point. And you're also right to say that progress has been made, like all parties involved, vendors, application providers, open source companies, to get us to a point that we can reliably scale out and scale down. And that's kind of an even more challenging problem. So scaling out is kind of, I would say it's a challenge, and it used to be a challenge. It's kind of not so much now, but it's an easier part of the challenge. So you like any scaling problem, the first thing that you need to answer is how much do I need right now, and what means more. Without having that information, scaling is kind of almost an arbitrary task. So an example of that is that you have this application. And then you're unaware of how much memory footprint, what's the memory footprint for it and how much you need. And let's say there's a memory leak somewhere as well, or you create a lot of strings and just, in a type loop or whatever that might be. And then you end up with a bloated memory usage footprint that then triggers scaling, for example, and it just keeps growing. And then you end up with the end of the month with a surprise bill. That is possible, it happens, but we need to answer those questions first. What is my normal? What is normal? What does normal look like? So therefore, what is more? And once you have those, and this is something that everybody kind of gets a feel of, is like it's kind of like knowing how you feel every day. You wake up, it's like I'm not feeling quite well, because you know what normal is. And that's kind of the same thing in application. If you have an infrastructure stack that you've been running for, let's say 6 months, you kind of know what to expect. And it then becomes all about putting those normal values, what is the normal boundary, into writing, into this manifest files that my so-and-so service or my web server or my Puma or my Sidekick uses this much memory should between this, and this. And if it grows out of that, then there is something either needs to be alerted or I need to be scaled. So that's the first part. And the second part is about scaling down. How long do I have to wait before I kind of try to shrink the footprint of my cluster? And all the 3 major cloud providers that provide managed Kubernetes, Azure, Google, and Microsoft, all 3 now offer auto-scaling. I think the best offer from the managed point of view of the 3 big cloud providers in this case is Google's, where they do automatic upgrades and patching and automatic scaling. And we've started using that. They used to be in beta, but Now there are not. They're out now. And we started using it kind of almost semi-automatically. We kind of enabled it, but we were getting we had to approve it before they decided to do this, so we can watch it and kind of almost nervously, because you don't want to under provision, obviously. And the benefit of scaling out is not as much as the benefits of actually we found scaling down. So think about it this way. If I have this, what we call a playgrounds cluster, we have a playground cluster that people can just play with it and use things. And this is the one that runs our PRs, basically creates an entire stack of every PR and Git ref and branch and tag and whatnot. You might have a national holiday, or you might have a offsite, which like the one that we had last week. The entire team is somewhere else, so you don't do as many development commits or as many PRs. So then you have this 40 server cluster that's just humming away, warming up the climate for no reason. So what would you do? And this is what we found actually shrinking down is the best thing. So we have these shrinking down auto scaling rules that just shrinks it down when we don't do as many PRs, or we don't have as much CPU utilization. And that actually helps us a lot with our builds and the bottom line when it comes to paying the cloud providers, as well as a lot of good other things that comes with. So a lot of people, when they think about scaling, they think about growth and more customers and more traffic, which is valid and very true, and it's a real problem and a real thing that I think should be answered. But once you have that, you can actually see other possibilities, and that's, if I want to have a full stack for every commit, how many servers do I need? It depends on how many developers you have and how fast you develop and what's the developer velocity and all that sort of other things. But then I have auto scaling on it, which means scaling the other way as well. So it means I don't need to worry about a surprise bill at the end of the month. So it's kind of a good thing.
Yeah. Well, is there anything else that you guys would like to talk about?
Well, it was a great opportunity for us to for me to tell you about a little bit about what we are up to. One of the things that I was talking to Chuck about this as well, and that's one thing that I think missing is in the market, and I think all the listeners to this great podcast can also help the entire community to steer and find or settle on the right solution, is that as Rails developers, we are very much about finding the best tool that does the job and be very pragmatic and want to get the results and get the job done without messing about with the yet another latest framework that has a new take on MMBC or whatever that might be. And that shows itself in every aspect, whether it's about databases, there is Active Record that does a great job. Obviously, there are other gems or frameworks or plugins that are available as well. But, we usually look at the options we have and we choose the one that's there. I mean, DHH is doing a great job in curating this list for the community. Essentially, that's what he sees at least his role. And I think he's done a great job in that. It's about Active Records doing that. There is Active Cable around real time, which is kind of recent-ish developments into this. So all these components that come about. That's like there is a new problem in the market, whether it's the web editing or whether it's real time push or anything that is, and then you have a set of things that are available to you, and we choose the right one. We add it to the set of the bundle of application stack that we have, which is Rails, and we kind of move on to the next problem. And that's a great way of building a reliable, plug-inable stack that you can then take it out and break it apart and use your own flavors if you want to, but whatever you have out of the box works. What we don't have now is the same similar approach when it comes to Kubernetes. We have had things like Capistrano, and we've had things that are very much have almost solved, to a great degree, solved the problem of deploying a Rails application into a VM. It's been a great success. There are again alternatives to things like Capistrano, but by and large, it's been a great thing. But what we don't have is the same thing for Kubernetes. What I see in the market is from the vendor's point of view, from the cloud provider's point of view, and those who provide managed Kubernetes, whether it's Amazon or DigitalOcean or whoever's managed Kubernetes providers, they look at it from both a generic and an infrastructure point of view. So it's very generic. It can handle any workload. It's not silly about Rails. And it's very infrastructure centric. Things about servers and VMs and about Siri thinks that it's yes, the answer. I don't know why, but it just showed up to say yes. Things around infrastructure where it's about components and constituents are infrastructure things. They're not application development things. And I think there is a gap here that we are, as one of the vendors in this market, active in this market, we are trying to address is that what does Kubernetes deployment mean for a Rails stack? When I have this, where is Sidekick? How can I have all these nice things about Kubernetes from deployments and ingress and services, all these fancy words. But what does it mean for my Sidekick? What does it mean for Puma? What does it mean for, active cable? How do I connect to a database, multiple databases, for example, from Rails application that's running in Kubernetes? So I think as a community, we can benefit from developing and settling on these standards and these components, whether it's a technology thing or a community best practices thing, that helps everyone benefit from this great technology that helps a lot of people without having to necessarily go deep into the nuts and bolts of how they work. The same way something like Active Record helped a lot of us to deal with databases without knowing SQL or the intricacies of an ORM system. And that's something that I really want to see us help with and learn from the community as well.
Awesome. Well, is there anything else that you guys want to add, or should we move on to picks?
I think I spoke more than my fair share.
Well, if people want to find you all on the internet, where should they look?
So we are available at cloud66.com. Our service is fairly simple to use and sign up for. We're also on Twitter at Cloud66. I am at Khash, Khash, on Twitter, and I'd love to talk to people who find this interesting or have something to add.
Awesome.
Hey, folks, I want to tell you about a great system that I just found that has made my life a ton easier. That's Cloud66. A lot of folks think that deploying is a pain. I kind of grew up as an ops guy, and so I never really felt that way until I tried Cloud66 and realized that the way that I was doing it with Capistrano, pushing stuff up to DigitalOcean, it really was kind of a pain. And when things didn't work, I had to go in and I had to bang my head against the wall to figure it out. Plus, all the setup stuff was just a big headache. And what I found with Cloud66 is that it's a really nice way just to get everything set up. I just told it I had a Rails app, and off it went. It set it all up, it does the deployment, and now that I have other developers working with me on Podwrench, which is what I'm using it for here, all I have to do is give them access, and then they can go push the button for me, and it gets deployed. It's really nice. It's straightforward. It has all of my environment variables in it, so I didn't have to do any setup that way either. I just had to go in, put in my AWS credentials and a few other things that I was using for third-party apps, and it set it up and ran it. So if you're looking for a great solution for deployments, use the promo code RubyRogues, that's all one word, capital R, Ruby Rogues, for $66 off Cloud66. This only works for new users, but man, it is awesome. So go check them out, cloud66.com.
Let's go ahead and move into picks. Andrew, would you like to kick us off?
Sure. And I'm sorry that I didn't have a ton to say, but I can just say that I learned a ton. So that was an awesome conversation. I'm still trying to take it all in. But my pick today is a GitHub action that I've been working on that's actually apparently some people are using, because as soon as GitHub changed their API and the action broke, a bunch of people came knocking. But it's called the RuboCop linter action. And what it basically does is you can just drop it in your project and it will run RuboCop against however you want to use it. Basically, it will use your configuration file that's in your repo. It supports all of the RuboCop plugins. And the thing it does differently that you can't do with actions out of the box is it will create annotations, almost like code review comments in the code, to show you okay, your line's too long, things like that. So I'm thinking about spinning a similar action out for standard RB, but yeah, it's RuboCop linter action. Check it out on GitHub. And if you have any problems with it, drop me an issue. And I'd love to take on more features with it.
Sounds really cool.
All right. Khash, do you have any picks?
Not for today. I don't think I can contribute to this.
And Kasia, do you have picks?
I think I will be a little bit selfish and I will talk about one of the open source projects we have, which is called Noticent, which basically is a Ruby gem for user notification management and can be quite useful for all the notification to set it up and get the alerts what's going on. That's
awesome.
me.
If you could just post a link to that in our chat here, we'll include that on the show notes.
Sure, will do.
I'll jump in with a couple of picks. So the first is from Sam's Club. Specifically, it is their Southern style chicken bites. And I swear, these things taste exactly like the Chick-fil-A nuggets. If you like Chick-fil-A nuggets, get these and throw them in your oven. They taste so good. So to pair with that, we recently got a air fryer from Cuisinart. It is awesome. So it's a toaster oven / air fryer combo. And I've just been cooking everything with that. So it's pretty awesome. And my last pick is on par with our topic today, and it's called Kubernetes. It is currently in beta, so it's free to download, but it gives you a desktop application GUI for managing a Kubernetes environment. So if you already have your Kubernetes config set up on your local machine, then you just run this application. It'll read from there, communicate with the API, and give you a visual interface of what's going on with your Kubernetes cluster. Well, that's all we have for y'all today. Thank you for coming and talking about Kubernetes and Rails.
Thank you.
Thanks.
Bye.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.